So somebody asked how we use the erythrocyte sedimentation rate in neuro-ophthalmology. And in order to know how to use it, you have to know what it is. So an erythrocyte sedimentation rate is the rate at which the erythrocyte sediments. So it's not a real fancy test, and it's the rate in millimeters per hour of the red cells sedimenting in a tube. So the red cells go to the bottom of the tube. The gravitational field of the planet is what's pulling them down. And normally the forces that are opposing the red cells from going down to the bottom is an electrical force, a potential, which is created by sialic residues on the red blood cell membrane that create a negative charge. So when the negative charge comes in contact or proximity to another negative charge, they're going to want to repel. So these are weak nuclear forces that keep the red cell apart. And we need that because we need to have the red cells pass single column through the capillary bed and not touch each other. So they have to be spaced properly. And it'd be bad for your red cells to all clump up together. Over time, however, the gravitational field of the planet will overcome this. And so if you leave it there for 10 hours, of course, all the red cells will go to the bottom. And that is going to separate the plasma component from the buffy coat, this middle part. And the bottom is the percentage that's your red cells. And that can be calculated as a hematocrit. So that is what they're calculating, is the percentage of the blood that is your red cells. And so when you have an erythrocyte sedimentation rate, it's a non-specific marker of inflammation, because any elevation in acute phase reactants in proteins, including C-reactive protein, but a whole host of inflammatory markers, they glom on to the red cell membrane and take away the charge. And when the charges are no longer present, the red cells will get all stuck together in a rouleau formation, and that rouleau will cause the red cells to hit the bottom, and they'll make the sedimentation rate go faster. So if you have a bad inflammation, like giant cell arteritis, your sed rate might be super high, like 100 millimeters per hour. However, anything that causes acute phase reactants to go up, malignancy, infection, inflammation of any type, that's why sed rate is not that great a test for specificity. What it's good for is sensitivity. It's good for capturing that something is wrong with you. So to me, in neuro-ophthalmology, I use the sed rate as a smoke alarm. It tells me something is wrong with the person, but it doesn't say what it is. And the thing we're really using it for the most is giant cell arteritis, but we use it as a screener for all sorts of systemic inflammatory or infectious diseases, just to see how much inflammation are we dealing with. So in giant cell arteritis, we're using the combination of the ESR, the CRP, and another acute phase reactants, the platelet count. Those three together give us an idea of whether we have the potential to have an inflammatory vasculitis called giant cell arteritis. And you need to know a little bit of how the thing works so that you can use it in the clinic.